Okay, here's a video on lesson 85, sample spaces and subsets, which is our first lesson under the topic of probability. So the first two things you need was a definition. A sample space is a group of all possible outcomes to an experiment. So if you roll a dice, a single dice is called a die. If you roll a die, you have 6 possible options. That's the sample space. What is a subset? A subset is a smaller group out of the bigger group. So in this case, we're talking about a smaller group out of the sample space that contains the desired outcomes. General probability is calculated by doing, let me pen a little bit smaller. General probability is calculated by looking at the size of the subset over the size of the sample space. And the notation that we typically use for probability is P of something. It's like P of A or P of 3. That means probability. Now, if I was looking at this, one of my first examples, one of these names is to be drawn from a hat. Determine each probability below. I've got Mary, Jenny, Bob, Marilyn, Bill, Jack, Jerry, Tina, Connie, Joe. There are 10 names. So the sample space is 10. Now the probability of getting a 3-letter name, well, how many 3-letter names are there? Bob and Joe. So remember, we're talking about how many fit the criteria. So we have 2 3-letter names out of 10 names total. So 2 out of 10 or 1 out of 5 if we simplified it. It's that simple. Now to move on from there was nothing really complicated at the bottom. So let's go to the back where we were talking about multiple trials. If that was good and you felt like that made sense and you haven't done anything on the front, you should pick a few questions from the front and make sure that you can do this as confidently as you think you can. Okay, so if so, just pause here, do a couple before you move on. Okay, now on to the back. Ands and ors. Ands and ors is really the goal of this lesson, is to teach you compound probabilities. So when we're dealing with multiple trials, we need the rules of unions and intersections. So first things first, what is a union? And just to keep this neat for you, what I'm going to do is I'm going to make some lines to follow. Okay. So what is a union? Including the symbol for a union, which actually thankfully looks exactly like a U. So a union, indicated like this, U, is an OR probability. And what that means is that if you could get one outcome or another, and that would be okay, one or the other, then what you're dealing with is a union. For instance, if you were going to the store and your friend was going to pick a drink for you at random, and you were okay with it being a Pepsi or a Coke, that would be a union probability. An intersection is more complicated. An intersection, all you got to do is flip the sign upside down. So let's take that U and let's just flip it upside down so it looks kind of like an N. That is messy. That is an intersection. That's a symbol for an intersection. So an intersection is an AND probability. So whereas a union is a little more, it gives you a little more leeway, a little bit of wiggle room, right? You could have one thing or another. An intersection actually requires you to do 2 things at once, or to do 2 things back to back. So intersections are less likely to happen. So an intersection would be like if your friend was reaching into a cooler to pick you up a drink, and there were bottles and cans of all different types of drinks in that cooler, and you needed to get a drink that was both a orange soda and a 20-ounce bottle. Now, you need two things to both go right, and for that reason, it's less likely to happen. So that's an and probability. And what you really just have to memorize is in a situation where you're talking about ors means we're adding. Ands means we are multiplying. You have to memorize those. So or is addition, and is multiplication. I guess I should say ors and ands. Now, so let's go through a couple of these examples and then move on from there. A bag contains 2 green, 9 brown, 7 yellow, and 4 blue marbles. Once a marble is selected, its color is noted, and then it is placed back into the bag. So this is called probability with replacement. That means that every time I reach in the bag to get a marble, it's still reaching out of the same group every time. The group does not change because I'm not taking anything out of the bag. So we need to find each of these probabilities. Probability of getting a brown. So the real question is, this is going to be equal to the subset over the sample space. So what I need is the number of brown over the number total. That's a simple probability. How many brown are there? 9. How many total are there? Well, 2, 9 is 11, 18, 22. So 9 over 22, and that cannot be simplified. That's the probability of getting a brown. Now for question number 30, it's a little more complex. We need the probability of brown, then not yellow. So hold on one sec. Okay, we're back. I wanted to give you a graphical diagram of what this looks like. Okay, so these are the marbles that we're talking about. So we agreed for 29 that it was 9 brown out of 22 total. Now for question 30, the probability of brown, then not yellow. So we have two things going on here. Do I want the brown or not yellow? Or do I need the brown and not yellow? Well, so that needs to be inferred by me. When I'm reading the question, I need to figure out which one makes the most sense. Brown, then not yellow, sounds like I need to do one and then the other. So this is an and probability. Anytime you need to do two things back to back and you need to do them both, that's going to be an and. So I need brown and then not yellow. So the way I can break this up is the probability of brown and the probability of not yellow. So the probability of brown, and means multiplication, the probability of not yellow. We actually have a symbol that we'll use for that later. Not can be written as this, a little bracket. But regardless, so brown then not yellow. So the probability of brown, we already know that. There are 9 brown out of 22 total. And the probability of not getting a yellow. So let's see. How many of these are not yellow? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 15 of those are not yellow. 15 out of 22. And now I'll just take this to my calculator. I'll multiply it. 9 times 15 is 135. 22 times 22 along the bottom is going to be 484. So that might be simplifiable, but I'm doing this in my head, so you'll have to check that in calculator. Okay, moving on. Green or blue. Very simple. Green or blue. Or becomes addition. So the probability of green plus the probability of blue. So let's see. How many green do we have up here? 2. And we have 4 blue. So what's the probability of reaching in and getting a green? That's going to be 4 out of 22. Plus, and the probability of getting a blue is going to be, oh wait, I mixed those up. 2 out of 22. And there are 4 blue out of 22. When you add those up, you get 6 out of 22. And that can be simplified into 3 over 11. Okay. Last one, just in case it blows your mind a little bit, the probability of yellow, yellow, yellow in 32. That means that I'm going to be doing the probability of yellow and, so times the probability of yellow, and so times again. Yes, you're going to multiply 3 things together. I have faith in you. It'll be great. You'll do fine. I will see you in class. If you have any questions on the back of here, try to figure them out from here. Otherwise, save them for after school for office hours. See you in class.